Utilization. Used in various laboratory and industrial processes for separating mixtures. Commonly employed in the preparation of certain food and beverages to remove sediment or impurities. 7.3.2 Separation of soluble solids. If the solid has dissolved in the liquid, it cannot be separated by the process of filtration. Instead, other techniques such as evaporation and crystallization are used. 1. Evaporation. Evaporation is a physical separation technique in which the solution is heated to its boiling point so that the liquid evaporates completely and leaves the solid behind. The simplest way to obtain salt from its solution is by slow evaporation as shown in Figure 7.12. Scan QR code on page 80 to access the detailed procedure and worksheet for Skill 7.10 to 7.13 part on evaporation. Evaporation. 2. Crystallization. A technique used to create crystals from a supersaturated solution is known as crystallization. It is used to purify a solid solute dissolved in the solvent of a supersaturated solution. A saturated solution forms when no more solute can dissolve in a given amount of solvent at room temperature. If the settled solute is then dissolved by increasing the temperature, adding more solute will also dissolve until saturation is reached again at increased temperature. At this point, further solute dissolution stops, and it begins to settle, resulting in a supersaturated solution. Utilization. One practical example of this technique is the production of pure copper sulfate crystals. Initially, a supersaturated solution of copper sulfate is prepared, followed by a slow and gradual cooling process. This results in the gradual growth of pure copper sulfate crystals. In everyday situations, you can witness crystallization, such as the formation of salt crystals in the Cura salt mine. In the chemical industry and laboratory, crystallization is often used to make very pure chemicals. It is also used in the pharmaceutical industry to separate and purify drugs. 7.3.3 Separation of liquid-liquid mixtures. If we want to obtain a liquid that is dissolved into another liquid, the process of distillation is carried out. Distillation, the apparatus used in this process, is shown in Figure 7.15. It is a physical separation technique that separates components through differences in boiling points. The technique involves two steps, i.e., evaporation and condensation. In the process of distillation, the mixture solution is boiled in a flask. The mixture with a low boiling point evaporates first. The vapors rise into the condenser, where it condenses back into liquid. The solid impurities and the liquid with a high boiling point are left behind in the flask. Utilization. In some countries such as Saudi Arabia, this sort of technique is used on a larger scale to obtain pure water for drinking from seawater. This process is carried out in a desalination plant. Petrol is distilled from crude petroleum through advanced distillation. Scan QR code on page 80 to access the detailed procedure and worksheet for Skill 7.10 to 7.13 part on distillation. 7.3.4 Separation of solid-solid mixture. Solids from other solids can be separated by another technique. It is called sublimation. To do so, we should pay attention to the individual physical properties of the components. If, for example, you wish to separate two solids, one of which sublimes, then this property should dictate the use of the sublimation method. Sublimation. In the case of an iodine-salt mixture, the iodine sublimes but salt does not. Iodine can be separated by heating the mixture in a funnel as shown in Figure 7.16. The iodine sublimes and reforms on the cool inverted funnel walls. The iodine thus obtained at the funnel is free from impurities that remain in the heating basin. Scan QR code on page 80 to access the detailed procedure and worksheet for Skill 7.10 to 7.13 part on sublimation. 7.3.5 Separation of components and dyes. What happens if you have to separate two or more liquid that are miscible into each other? This type of problem is encountered when you have mixtures of colored materials such as inks and dyes. A technique called chromatography is widely used to separate these materials so that they can be identified. Chromatography. It is a physical technique based upon affinities of the mixture's components with that of filter paper because each component is of different sized particles. To separate the different colored dyes in a sample of black ink, a spot of the ink is put onto a piece of chromatography paper. This paper is then set in a suitable solvent as shown in Figure 7.17. As the solvent moves up the paper, the dyes are carried with it and begin to separate. They separate because the substances have different solubilities in the solvent as well as different affinities with the filter paper. Therefore, colored particles get absorbed to a different degree by the chromatography paper. As a result, they are separated gradually as the solvent moves up the paper. The chromatogram is in Figure 7.17. It shows how the ink contains three dyes, P, Q, and R. A scan QR code present on page 80 to access the detailed procedure and worksheet for Skill 7. 10 to 7.13 part on utilization. Chromatography is widely used in forensic science for the identification of samples taken from crime scenes. In pollutants monitoring to identify unknown pollution in air and water samples. to study complex mixtures such as in food, perfume, petrochemical, and pharmaceutical drugs.